Hi everyone, we are Team 18 and we are going to talk about how we do this project. We will present this work in 4 parts. First, we will introduce the methodology we use in this work, and then the evaluation part to improve our models. Then we will show our project's test results and the result on the demo dataset. Finally, we will discuss and conclude the results and the problems we encounter in our work. Let's start with the methodology we implement in our work. We implement 3 CNN models and a AlexNet model to construct our classifier. For the CNN models in our work, we apply the similar idea in the sample code and method modification. One of the changes is that we adjust the number of the layers in each of the CNN models to improve the performance in the grade classification task. On the right-hand side shows the parameters we set for our CNN models. We use ADAM as our optimizer, and we modify the learning rate to 0.001. We also introduced an AlexNet model in our work, and the right-hand side shows the architecture of it and the parameters in our AlexNet model. We introduce a majority voting mechanisms to realize ensemble learning, taking the label classified by the 3 of the best models in our work as input. Our voting algorithm will output the label that appears the most frequently, which will reduce the bias caused by a single model. And here is the data augmentation part. We use DCGAN to implement data augmentation. We first separate the test case into 3 different groups, A, B, and C. Then we take each group to put into the DCGAN model and train it. The sample picture on the right-hand side shows the epochs of our DCGAN, and the epoch we choose depends on what we actually need. And this is the testing result of our work. Each of the model alone can perform an above 70% accuracy on the testing dataset. We then choose 3 models with the best performance, which is CNN1, 2, and 3, to implement ensemble learning. And the result of it also shows on the right-hand side. We can see that the overall performance is above 75%. And after applying ensemble learning, the result outperforms most of the individual results. Our classifier has a 75% accuracy on the demo dataset. Most of the misclassified cases are those misclassifying Class B to Class C. Our classifier performs almost perfectly when classifying Grade A and Grade C mangoes. We found that using Google Lab to read image performed poorly, so we spend lots of time reading image. When training our models, the accuracy may not improve at all at some point. To fix this, we set the learning rate smaller and then run the experiment with different optimizers. When validation loss started to increase tremendously, we stopped training in fear of overfitting. And here is our conclusion. First, unlike general classifiers, we have to divide the samples the same species, mango, into 3 different classes instead of recognizing different species, like cats or dogs. Therefore, what we are going to do is to identify the subtle difference between mangoes. Second, we try to use ResNet VGG16 in our project initially. However, the outcomes of these classifiers perform worse than we had expected beforehand, because these models are designed to recognize 1,000 classes. Thus, we eventually decide to build the structure of CNN on our own in order to let the model detect more minor difference. In fact, after being modified, the predicted results are better than the original model. More, better than the baseline announced by the official website. And this is all for our presentation. Thanks for listening.